Hello and welcome back to another episode of It's Dr. Dan, and today we're going to be learning about different types of chemical reactions. So when it comes to chemical reactions, there are a few major types you're going to come across in general chemistry when you're learning about these. Now, the whole idea about learning the different types is so that way you can predict what kind of products you're going to come across when you are introduced with two initial reactants. So what we learned about when we learned about how to balance chemical equations. So we're going to go through each type and then we're going to try to predict what it is exactly that we will be making following a very simple recipe. So for these different types, I would recommend writing down the little recipes. That way you can try to see what components you have. So for the first one, combination synthesis. With combination, it's exactly what that name is. We're going to be combining two different things together. So we will have two or more substances and they'll combine into one single new product. So if we have two separate things, a really simple way to put that, A plus B is equal AB, right? We're taking A and B and we're mushing them together to make the same exact thing. So an example of that type of reaction would be, let's say if I had two different species. What if I had hydrogen gas reacting with bromine gas? So with this, we can kind of see we have two of those individual parts. Now they're going to be coming together. Now, when we're predicting this, the way that we're going to be assigning letters is essentially for hydrogen. Hydrogen is a single element. That's going to be an A. Bromine is a single element. That's going to be B. And it's going to be creating AB. Now, you don't want to just write that it's going to be H2Br2. That's not an actual chemical formula. So we have to go and write down try to think how many bonds can everything make? Well, hydrogen can make a single bond. Bromine can also make a single bond when we're looking at this specific interaction. The other way to try to remember too is if you remember all the charges, we're going to have to be dropping them along so it builds off of everything that you've learned previously in chemistry. So being that it's a plus and a minus, they are balanced. So we have a correct product. But we have to also go through the process of balancing it. So if you can see on the right, on the left-hand side, we have two hydrogens. We only have one on the right-hand side. We also only have one bromine on the right-hand side of the reaction, and two bromines on the left side. So with that, how can we easily balance it? Well, we can add a 2 coefficient out front to balance our reaction. So not only are we predicting, but we're also going through a balancing act as well. So it's a lot of different pieces all coming together. The next major type is a decomposition reaction. Decomposition is when one substance breaks apart and forms two separate products from this. So we start with one and we break into two. So we're decomposing or breaking down. This is the opposite of the one we just talked about. So if we are to be going through something that's like decomposition, well, we got to go through a very similar process. So let's say if I give you a starting reaction of HGO, so mercury oxide, and I asked you, all right, well, how would this break down? Well, we would assign our little letters, right? A would be for mercury, B for oxygen. So that means it's going to be breaking down into its individual pieces. So it's going to break down into mercury and oxygen. Now, one thing about this is we have to remember other little skills. If you have individual elements forming, we have to remember our diatomics as well. So if you remember the 7 diatomics, just to kind of write those down for ourselves. So if you remember, have no fear of ice cold beer, this is going to help you a lot for future reactions. So being that oxygen naturally forms O2, we have to remember to write that subscript there. Same thing when we're balancing charges, we're always checking our subscripts. Now, is this a balanced reaction? Right now, you'll see that there's 2 oxygens on the right-hand side, and there's 1 oxygen on the left. So how can we easily balance that? Well, if I put a 2 in front of HGO, that balances our oxygens. but now our mercuries are in balance. So now we'll balance that one. So it's decomposition. We broke down mercury oxide, and then we made mercury and oxygen gas as a result. The next type is when we're looking at a single replacement reaction. So this is when one element in a compound is going to be replaced by another element. So the way that I showcased this was we have A as an element, and that's going to be coming in and replacing our B in this case. So when that happens, A is coming in, it's going to replace B, and then B is going to go away. So this is a singular replacement. So being that this is a single replacement, there's a couple little trends that are easier to remember here. Elements that tend to form cations will replace other cations. So for example, for A here, a lot of times this tends to be a metal. Metals generally will form cations. They have a positive charge. So if we have an ionic species that it's reacting with, well, it's going to replace the cation. If you have A, let's say if A instead is something that makes an anion, maybe like if it's like a gas, like chlorine or bromine gas, iodine gas, these ones are going to be forming anions, so they'll replace the other portion of it. So let's look at an example of that. So if I go through this and I say we have copper reacts with zinc chloride, how would this reaction occur? Well, copper is a metal, right? So that's going to have a tendency to make a positive charge. So we can assign our letters, right? So this would be A plus B, C. And what that's going to be creating is A is going to replace B, and then A and C are going to be created. So copper is going to replace zinc. That would be one product. And then we're going to be creating copper with chlorine in our final product. Okay, so now in order to go through balancing these, we got to look at how many of each species do we have. Well, one thing you'll notice is actually everything is balanced in this one. We don't have to do anything with it. So this one's already balanced. The only way that this might require balancing is depending on which form of copper you have. This one is a 2+. You could also have a 1+, which might affect your balancing. But you can see that copper replaced zinc in this reaction. Zinc went away and it went into by itself. So we replaced one single element. The next one is double replacement. So with double replacement, the entire idea with this one is that we have two compounds reacting in an aqueous solution. So whenever I say aqueous, that means that we have generally an ionic species that is in a aquatic solution. So it has water around it. So whenever we have water, this is something where the cations and the anions, they're going to be trading with one another. So with this, if I say that's going to be trading, the best way to remember this one is think of inside, outside, meaning that the things that are typically cations in these, so these larger ones are cations, these two are going to be trading we're going to be trading places with the different parts here, meaning when this is happening and we're trading our cations, A and C are going to be trading, meaning that A and D are going to bond together, so the outside bond, and then the inside bond together. So we're going to be trading. So what would be an example of that? Well, being that this is in an aqueous medium, we can say, what if I had silver sulfate, and this is going to be reacting with sodium chloride? What would I be creating? So from this particular example, we're going to be trading our inside and our outside. So we're going to be taking our silver, and that's going to be bonding to chlorine. So why don't we write that over here? So AgCl. We'll write our charges to make sure everything's balanced. In this case, we see silver has a +1 charge, chlorine has a -1 charge. So you have to look at your periodic trends. With sulfate and sodium, they're going to be bonding together. And let's do that in a different color. So sodium and sulfate, we will have those. So it's Na+, and then sulfate is a 2-. So they're going to trade charges, so swap drop, meaning that it's going to be sodium 2 with just a single sulfate. All right, now with balancing, we have to make sure that we are checking all of our how many of each species we have. So these are a little bit tougher to do. The first thing you want to do is start with the polyatomic, right? So we have a single sulfate on both sides. We see that there's one on both. So let's start with the sulfate on the left, the one that's bound to silver. So we'll now balance the silvers. So we're doing the zigzag method. Start with sulfate, that's balanced. We're now going to go to silver. We see that there's 2 silvers on the left-hand side, and there's 1 on the right. So we will add a 2 in front of here. We'll then go to the chlorines. We see that, okay, well now there's 2 on the right. We now need 2 on the left. And the sodium's balanced as a result of that as well. So we have a balanced chemical equation. But this is double replacement. It's all about trading. Remember, inside, outside. The outside bond together, the inside bond together when you are going through those types of reactions. So there's 2 more. So we have combustion. So combustion, if you think about how does your car move? How do you heat your home? It's all about burning fuel. So, and that's the most common example that you'll see in general chemistry. So if I want to burn a fuel source, generally what is going to be happening is you have what we refer to as a hydrocarbon. So a hydrocarbon is hydrogen bound to a carbon. It's the simplest fuel source. Think of like propane gas, gasoline, methane. These are things that are a hydrocarbon. So whenever we are given a hydrocarbon, let's say if I pick methane, the end part of the reaction is always the same, no matter what. So oxygen, every gas needs to burn with oxygen. In order for fire to happen, we need for it to burn with oxygen. So CH4 is going to react with O2 as a result. Let's make these a little bit bigger. So CH4 is going to be reacting with O2. Now that's going to be creating CO2 and water. Now what we need to do is check, is everything balanced? And the one thing that you'll notice, carbons are balanced, the hydrogens are not. So one thing we can do is we can put a 2 on the right-hand side. That's balanced. The oxygens, we have 4 on the right, only 2 on the left. So we can balance that with a 2. Then we have a nice balanced combustion reaction. So it's all about the burning of different fuels. Now, the last type of reaction, so this is going to be one that I'm going to make a separate video on by itself. But this is something that you're going to come across because it's a subtype of a lot of single replacement reactions, as well as sometimes for double replacement and combustion too, but mainly single replacement. So what this one is all about is how your batteries work in your cell phones, your laptops, all your electronics. It's all about how we can conduct electricity, which is in the form of electrons being transferred from one place to another. So in oxidation and reduction, it's how do we transfer an electron? So I made one here with just zinc and hydrogen. So zinc, in this case, is transferring electrons to hydrogen to help power something. So what this is referring to is writing out all the charges or oxidation states of these different species. So we're always writing out the charges, which are oxidation states. And this is something you're checking in all reactions to see like, okay, is everything balanced? And sometimes you're going to see the charges on different species are going to change as a result. So when this happens, so if I have zinc reacting with 2 hydrogen plus ions, we're going to create zinc ion and H2 gas. So you're going to see some bubbling come off. Now, if we look at the different pieces of the reaction, zinc with a 0 charge turns into zinc 2 plus. So this one lost 2 electrons. When you lose electrons, that is oxidized. Okay, so lose electrons is oxidized. Now the opposite is when you gain electrons, you are reduced. So hydrogen in this case gained 2 electrons, so it was reduced. Now this is the final type of reaction. So the main 5 are these first ones that we covered, but you will commonly see oxidation reduction too, which we will cover more in the future. I hope that this video helped you be able to see the different types and maybe practice a little bit of balancing as well. But feel free to tune in for future videos. We're going to be coming up with some new ones in the near future, being that we're always producing them. I look forward to seeing you in the future, and this has been Dr. Dan. Please hit that like, comment, subscribe button. Keep the channel going, and I really appreciate all of your support out there. All right, bye, and I'll see you all later.